So we introduced the idea of the side splitter yesterday. So join me on page 35 for a few minutes, and let's recap some things that we've seen and see a couple new things. Well, when we have a triangle like this, and we draw a parallel line like we looked at, this DE right here, it takes this big triangle and it cuts it into two triangles. And we saw that when that happens, we can make some nice proportions because these triangles are similar. We have a small triangle up top and a large triangle, and they are similar by angle. So let's think about these relationships once again. So we could take this left side AD, and if we compare that to this long left side here, AB, so we could say that short left side over the long left side is equal to the short right side, this one right there, AE, over this long side AC. Well, now let's look at a couple different relationships that also happen. So that's like short side over long side, short side over long side. So those are some proportionality statements that we looked at there. Okay. Well, let's look at this situation where if we take this triangle, you can join me down on the bottom of page 35 there. All right. So here we had a situation where Tia and Tristan were thinking about this situation. And Tia had this idea. I'm going to write a little differently than is written here. Tia said that, well, we got these similar triangles, and we've got these pieces. I'm going to call this piece A, and this piece B here. So B is the length of this little piece. A is the length of that little piece. And let's go over here, and let's call this length C. Notice I'm using lowercase letters there. And length D here, all right?
All right.
So what Tia was saying, Tia's saying this. Tia thinks that if we take this length A divided by this length B, this little piece, that's going to be the same as this length over this length. Okay, so that was her idea. Let me write that down. She's thinking A over B equals C over D. And Tristan was saying, wait a minute, that doesn't make any sense because this is not a length of a side and this is not a length of a side. Well, let's look into this a little bit and see if she's on the right track. So if we have we know the long side here, A plus B, that's the long side, divided by the short side, A. So if we take the long side over the short side, that should be the same as the long side over here, C plus D, over the short side, which is C. Sorry, the short side is C, right? Okay. Well, I think we would agree with that. So now using what we know about fractions, we can actually rewrite this. This is the same as A over A plus B over A equals C over C plus D over C. Because when we add fractions, we just add the numerators and the denominator stays the same. Okay, jot this down with me if you're not, all right? So, well, what is A divided by A? Well, 5 divided by 5 is 1. 10 divided by 10 is 1. So anything divided by itself is just 1. And what do you know? I've got 1 on both sides there. We can subtract 1 from both sides, and look what we're left with. I have B over A equals D over C. Okay, so that's saying this little piece over this little piece is equal to this little piece over this little piece. Or if we wanted to flip that around, it would also be true to say A over B equals C over D because we just flipped the fraction, which is what Tia was saying. So this is what we call the side splitter theorem. And it's really useful. It's useful because when we look at this situation where we have parallel lines, it's kind of cool, but these two sides, A over B, it just makes a proportion. Look at that. A over B equals C over D. Pretty cool, huh? and that's the side splitter. Now, if you look at the next page, we've got a situation where if we have even more lines, what if we take this triangle and instead of just having one line, we have a couple lines? Notice there's our original triangle right there. We got a whole nother triangle or a whole nother line here. Okay, well, the same thing applies here. So if we take this and let's call this little a, let's use a different color here. Let's call this little a, little b, and little c. So little c is this little space in between here. We'll call this little d, little e, and little f right here. So those are the lengths. So f is the length of this piece, e is the length of this piece, so on and so forth. Okay, well, we just said a moment ago that this piece A over this piece B is equal to this piece D over this piece E. That ratio should be the same. Well, what do you think will happen if I take these two pieces? Can you think of an equivalent ratio here if I say B over C? If I put B over C, what do you think that would be equal to? Well, just look over on the other side. We can have E over F. Okay, kind of cool. So we can take any corresponding parts as long as they line up. Okay, and we can even take it like this. We can even say, well, let's compare these two, and let's say A over D. That's like a left over a right. And we could say, all right, well, let's find another left over right. How about this one? How about this left piece C over that right piece F? So that works because we have left over right, left over right. Notice left over right, left over right. So there's lots of different relationships we can do. But the key is if these lines are parallel, the parts are proportional. So if you flip with me to page 37 here, then we'll summarize this and get to work. So if we have a triangle here, and we have cut it with some parallel lines, the key is that those parallel lines will cut the two sides into proportional parts. All right, so a triangle cut by parallel lines will make proportional parts. So if we take a triangle, we cut it by parallel lines, okay, we'll, let's say, divide the sides into proportional parts. We'll divide the sides into proportional parts, okay? Parts that make proportions, proportional parts, okay? So the big idea, once again, let's draw a picture of it real quickly if you didn't get this the other day. If we have these parallel lines, these are parallel, A over B equals C over D. So we can say if these little pieces, if these are the lengths, then A over B equals C over D. And this is called the side splitter theorem. All right? Well, let's try a couple out here, see what you can come up with. Here's two examples on page 38. Why don't you give it a try? Can you make a proportion for A here? Try it. Make a proportion. Here we've got a triangle cut by two parallel lines. Do you see the proportion? Try writing it if you see it. We've got these two parts on the left and these two parts on the right. How about this? 6 over 3 equals 2x over 5. So it just makes, if you turn your paper or turn your head, we see 6 over 3 equals 2x over 5. There you have it. And there's a proportion we can cross multiply. We get 6 times 5 equals 3 times 2x, which is 30 equals 6x. Divide by 6, and we get 5. Okay? X equals 5. Okay. All right. Well, how about this one? we've got parallel lines, so it breaks these sides into proportional parts, okay? Now, notice this part is x, this part is 10, this is 3. How long is this one? Is it 18? Nope. It is, how about 18 minus 3? Yeah, that'll work. It's 15. So we could write our proportion in several ways. We could say 3 over 15 equals x over 10. But just to show you that it works, what if we did this? Let's take these two pieces from that slice, and these two pieces, we could say x over 3 equals 10 over 15. Okay? Several ways to write this first proportion. But if we cross multiply, we get 15 times x equals 3 times 10. 3 times 10 is 30. So let's divide by 15. And we get x equals 2. All right. There you have it. So that is the side splitter theorem. That's how it works. So why don't you go ahead and give your assignment a try now and see if you can find some missing parts with the side splitter.